In this video, let's talk about recursive sequences. So I'm going to bring back that initial image we had of this sequence, 1, 3, 6, 10, 15. So we have the first 5 terms of this sequence. Could you tell me what the 6th term would be? So to go from term 1 to term 2, we add 2. To go from term 2 to term 3, we add 3. From 3 to 4, we add 4. And from 4 to 5, we add 5. So to get our 6th term, we need to add 6 to the previous term. So 6 plus 15 means that our 6th term will be 21. And real quickly, the 7th term would then be 21 plus 7. So our 7th term would be 28. So what we're discovering with this sequence is that each term depends on the previous term. In other words, you get the next term by adding the previous number to this n value. This is known as a recursive sequence. In a recursive sequence, terms are defined by previous terms. So the general idea is that you'll be given the first term, and once you know the first term, or maybe the first few terms, then you'll give the rule for the sequence, and that rule will be based on the previous terms. So let's give this a try. We're going to write out the first 6 terms of the recursively defined sequence. So our sequence A is given to us as the first term is equal to 1, and any arbitrary nth term is equal to n multiplied by a sub n minus 1. So what this means is that you're going to take whatever term you're on, right? So the nth term, and then you're going to multiply that by the previous term. So a sub n is the nth term. A sub n minus 1 is the term before the nth term. So again, we already know what the first term is. That's given to us as a1. So the second term is going to be n, so that's 2 is n, so that's this part right here, multiplied by the previous term. So let me use the subscript here. So a sub 2 minus 1, well, that's going to be a sub 1, because 2 minus 1 is 1, right? And a sub 1, the first term, we know was 1. So the second term is 2. The third term is going to be 3 times a sub 3 minus 1. So 3 minus 1 simplifies to 2. So we're going to take the number 3 and multiply by a sub 2. So a sub 2 is the second term, and we know that the second term was 2. So our third term is 3 times 2, which is 6. The fourth term is going to be 4 times a sub 4 minus 1, which is 4 times a sub 3. A sub 3 was the previous term before this one, which was 6. So my fourth term is 4 times 6, which is 24. My fifth term will be 5 times a sub 5 minus 1, which is 5 times a sub 4. The fourth term was 24, and so 5 times 24 tells me that my fifth term is 120. So again, you can see that each term is dependent on the previous term. So the way that we got this 2 was to multiply 2 times the previous term, 1. The way that we got this 6 was to multiply 3 times this previous term, which was 2, which gave us 6. The way that we got 24 was to take 4, which is the number term that we're on, and multiply 4 times the previous term, so 6 times 4, which gave us the 24. And the way that we get the 120 is by taking 5 and multiplying it by 24. So how are we going to get our 6th term? Our 6th term is going to be 6 times the previous term, which was 120, which gives us 720. So a sub 6 would have been 6 times the 6 minus 1 term, which is the fifth term, and the fifth term was 120. So our sixth term is 120. So let's return again to our picture here of the sequence. So we know that A1 is 1, A2 is 3, A3 is 6, A4 is 10, A5 is 15, A6, remember what the rule was for this? You add 6 to the previous term in this case, so that's going to be 21. A7 would be to add 7 to the previous term, so that's 28. So this is a recursive sequence, but what is the rule? Find the formula for this recursive sequence. So maybe we're given the first term, which is A1, but how do we define subsequent terms? How do we define the nth term? Well, we took that n and we added it to the previous term. So similar to the example we just did, we're taking n and adding it to a sub n minus 1. So let's make sure that this works, right? So A2 would be 2 plus a sub 2 minus 1, which is really 2 plus the first term, which is 2 plus 1, which gives us 3. A3 would be 3 plus the a sub 3 minus 1 term, which is really the second term. And the second term was 3, and 3 plus 3 gives us 6. Let's get down a bit here. A sub 7 is going to be 7 plus a sub 7 minus 1, which is really 7 plus the sixth term. The sixth term is 21, and 7 plus 21 is 8. So we did it. We found the rule, the recursively defined rule for this sequence. I should say, though, that part of this rule is that a sub 1 equals 1. You have to know the first term in order to give this rule.
Let's build a recursive pattern using squares. Let's start off with a 1 by 1 square, and right next to it we'll put another 1 length unit square. Together those squares have a length of 2, so next to those we'll form a 2 by 2 square. Then those shapes form a length of 3, so then we form a 3 by 3 square. And we keep adding in this fashion in the spiral pattern. So 3 plus 1 will give us a 5 by 5 square. And then we'll have a 5, 1, and a 2 to form an 8 by 8 square. Now we have an 8 plus 2 plus 3, which is going to give us a 13 by 13 square. Our next square will have a 13 plus 3 plus 5, which will produce a 21 by 21 square. And then I can only fit here part of the next square, which will be a 34 length square. We can describe this pattern as that each number is created from the sum of the previous two numbers. So the 3 length came from the previous two terms, which was a 2 and a 1. The 5 length came from the previous two terms, which was a 3 and a 2. Your 8 length came from the previous two terms, which was a 5 and a 3, and so on. If we list the terms of the sequence, our first term is 1, our second term is also 1, our third term is 1 plus 1, which is 2, our fourth term will be 1 plus 2, which is 3, our fifth term will be 2 plus 3, which is 5, our sixth term will be 3 plus 5, which is 8, and then we'll have 5 plus 8, which is 13, 8 plus 13, which is 21, and so on. A recursive formula for this sequence is that any nth term can be found by adding the two previous terms. So that's annotated using a sub n minus 2, so that is 2 terms before, and then a sub n minus 1, that's the term before that. This sequence actually has a name. It's a very famous sequence called the Fibonacci sequence. And lots of things in nature have this sort of spiral pattern. Broccoli, sunflowers, seashells, succulents, all have a spiral pattern embedded within them.